Please write junction rule and loop rule for this circuit and use them to find the current in each resistor. The battery pumps the current out of its positive terminal. I will call this current I of the battery. When it gets to this junction, the current splits into I1 and I2. If I write the junction rule I in equals to I out for this point P, I would have I battery going into the junction and both I1 and I2 going out of this junction. So I battery equals to I1 plus I2. For loop rule, we have two loops to write for. Actually, we have three loops: the top loop, the bottom loop, and the big loop. But we only need to write loop rule for any two of the three loops, because the third one can be obtained by combining the other two. I will start with the loop rule equation for the bottom loop. Starting from point P and follow the current clockwise. I'm following the current and go across a resistor, so the potential is going to decrease. It's going to decrease by I times R. So this will be I1 times R1. And then I'm going across a battery. I'm going from the negative terminal to the positive terminal. So the potential is going to increase, and it is increased by the voltage of the battery. So plus V sub battery. Now I'm back to the starting point. So this delta V for a closed loop should equal to 0. I can move this term to the other side. So I have the voltage of the battery equals to I1 R1. And that means I can find I1 equals to the voltage of the battery divided by R1. And that is the current in R1. Now I'm going to write one for the big loop. Again, I will start at point P and follow the current. So follow the current, go across a resistor, the potential is going to decrease. So delta V would equal to minus I times R, and this time it's I2 R2. And then nothing over here, and then we're going across the battery from negative to positive terminal, so it's a plus, and the potential difference provided by the battery is the V sub battery. Nothing here, and then we're back to the starting point. For a complete closed loop, the delta V should equal to 0. We can move this term to the other side, so the voltage of the battery equals to I2 R2. That means the current in resistor R2 is the voltage difference provided by the battery divided by R2. Although there is no need to write one for the third loop, I will do it just to show that it is indeed redundant. For the top loop, I will start from P again and follow I2. When I'm following the current, the potential is going to decrease, and it is going to decrease by I times R, so this will be I2 R2. Nothing here, and then when I go this way, I'm going against the current. If I'm following the current, the potential is going to decrease. So if I'm going against the current, the potential should increase. So it's going to go up, increase by I times R, which is I1 R1. Now I'm back to the starting point. So the total delta V for the closed loop should equal to 0. Which means if I move this term to the other side, what does it give us? It's I1 R1 equals to I2 R2, which is redundant because over here we know the voltage provided by the battery is I1R1 and it is also I2R2, which means that they are equal. Of course, for this problem, we can also use Ohm's law, V equals to IR. These two resistors are in parallel because they have one end together, the other end is also together, and they are in parallel with the battery. So they get the same voltage as the voltage difference provided by the battery. So for both resistors, the voltage is the V battery. And for R1, this voltage equals to IR. For R2, the voltage equals to IR as well, I2R2. So of course, we'll end up with the same answer. To find I1, we can divide by R1 on both sides to get that. To find I2, we divide by R2 on both sides to get that.